Hello, today we are going to take a look at problem 856, score of parentheses. In this problem, we are given a balanced parentheses string S. Compute the score of the string based on the following rule. So the rule being, if this, we give it a score 1, and this we give it a plus b, and this we give it 2 multiply a. So let me explain this. This problem is we have to determine the score of our parentheses string. So this is 1, so 1 parenthesis is 1 score, but if there's another 1, it becomes 1 plus 1 equals to 2, so it's plus, sum up. So if it is inside this is 2, right? We already know this is 2, so if we add 1 parenthesis, this will be 1 plus 1 multiply 2. This effect is the same as multiply 2. So if we keep adding this, then we're going to multiply more 2, something like that. So our job is to find out, to get the score of the string based on this rule. Now let me introduce the algorithm to solve this. The algorithm to solve this is simply, let me get rid of this. Okay, so the algorithm being, we iterate. So in this example, which is example 4, we get the result is 6. So it's 1 plus 2 multiply 2, which is 6, right? So how do we apply our algorithm to this problem? Which is, we go through every letter from left to right. We iterate through this string, and when we find this, we add the layer. So this equals to layer plus 1. And when we find this, we do 2 things. Of course, first we decrease the layer, and this is the first thing we do. And the second thing we do is we will check the previous one. Check previous one. If it is this, then what we will do is we will add this to our result. As 2th layer. So the reason being, so for example, we iterate this through in this step 2, so in the second character in this string, we find out this. Our layer is 1 plus 1 plus 1, which becomes 2 at this point. And our result is 0. Our initial value, 0. And when it goes to 3, because it's this, it's the right side of parentheses, so we minus 1, so layer becomes 1, and result we have to check if the left, so if the previous one is the left side, so it is, so we add 2 to the power of layer to our result. So we do the same. At 5 we get 3 layer, and then we at 6 we have to check if the previous character is a left side, which it is, so we add, then we get 6 at this point. Then at 7 and 8 we just decrease our layer, since the previous character is not the left side parenthesis. Okay, so this is how this algorithm works. The reason it works is because in this question S is a balanced parenthesis string, so we are guaranteed S is a valid string. Therefore we only have to, therefore, and for example here in the step 6, based on this, so if there is a, if we know the previous characters, so if there is a right side, then we can know there must be, we can know the rest because it's a valid string, so we don't need to know the rest. Therefore we can just use layer to count how many wrapped parentheses there is. So yeah, so let's get into coding. First we need 2 variables. So the first variable is the layer I talked about, and the second variable is result. They're both initially 0. Then we iterate through the string. So if SSI is equals to left side, then we will increase the layer, else we will decrease the layer. So if the previous character is this, then we will add 2 to the power of layer, and now we return our result. 13, okay, a typo. Yes, so again, why this works is because it is a balanced parenthesis string, so it's guaranteed to be valid. Therefore, we can just count the layer to know how many wrapped parentheses there is, so we can know which at which point parentheses 2 section of parentheses like completed, then we can add them up at the end. And so if you look carefully, you will notice there, so for I in range of length of S, if when I is equals to So there's a bug here, but it won't happen because it's guaranteed to be a valid string, right? So if when I is 0, if of I is equals to this side, then it will crash, because, and why it's because so it will check, so it will decrease layer, which will becomes like -1, and it will check is of I -1, which is -1, which will check the last number. It won't crash, but it will be a bug. Yeah, but the reason here it is not a bug is because it's guaranteed, not guaranteed valid string. Yeah, if it's like something like start with this, because a valid string won't start with right side parents. Yes, so that's how this solution is.